indexing method is used to divide the periphery of a workpiece in equal number of parts. Why indexing is done, or what is indexing? Indexing means to produce any number of equal parts on the to the periphery of the workpiece. Means if we require the equal number of divisions to be equal number of divisions required on the periphery of the workpiece, then we will go for indexing. The indexing head is the operations of dividing the periphery of a workpiece into any number of equal parts. That means, if this is the workpiece, this is the circular workpiece, if we will require to divide equal number, this is one part, 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 one part. Here 10 equal parts, here 10 equal parts. Equal parts means if we will divide this workpiece, into 10 equal parts, how it should be done? Now, by indexing method, we can divide the workpiece surfaces or periphery of the workpiece into equal number of parts. While cutting the spur gears, an equal spacing of the teeth on the gear blank is performed by indexing. Equal spacing means, if this is a spur gear, and this is number of teeth, then spacing is the gap between these tooth. The gap between the teeth is called spacing. The gap between the consecutive teeth is called spacing. Then we should then in the preparation of the spur gear in milling machines, we have to divide the periphery of the workpiece or the gap between the two teeth into equal number of spacings. So, in this case also we have to go for indexing. The indexing head can also be used for producing a square or hexagonal bolts. Cutting splines on shaft, fluting drill, tap reamer. In this case also we go for indexing. The indexing can be achieved using a special attachment known as dividing head or index head. We will go for indexing. How? Means we can divide the workpiece into any number of equal parts by attaching a dividing head or indexed head in the milling machines, by attaching a dividing head or indexed head. Then there are total 5 indexing methods. One is direct indexing, another is second is simple indexing, third is angular indexing, fourth is compound indexing, fifth is differential indexing. But in our syllabus, this one is present, this one is present, and this one is present. Means we will discuss about direct indexing, simple indexing, and compound indexing. For these indexing, we will require for different dividing head or index plate. Dividing head or index plate. Index plate is used. Index plate is used in milling machine for dividing equal number of parts of the workpiece. Equal number of parts of the workpiece. Then there are 3 types of dividing head. One is plain dividing head. One is plain dividing head. Second is universal dividing head. Second is universal dividing head. Third is optical dividing head. third is optical dividing head, third is optical dividing head. Means there are three types of dividing head. This is plane dividing head, another is universal dividing head, and the last one is optical dividing head. By using this dividing head, we can by using this dividing head in milling machines, there is a total 5 indexing head methods. So, one is direct indexing, simple indexing, angular indexing, compound indexing, differential indexing. But here in our syllabus, direct indexing is there, simple indexing is there, and compound indexing is there. We will discuss one by one. Then we will see direct indexing. What is direct indexing? Direct indexing is also called rapid indexing. Direct indexing is also called rapid indexing. Why rapid? In direct indexing we use bevel gear. We use bevel gear arrangement in direct indexing. The direct indexing is also called rapid indexing and is used when large number of pieces are indexed with a small division. Large number of pieces are indexed with a small division, then we use direct indexing method. These operations can be done in both plane and universal dividing head. These operations can be done in both plane and universal dividing head. When using the universal head, the worm and worm wheel are first disengaged. While used the universal head, and the required number of divisions of the workpiece obtained by means of the rapid index plate, which is fitted at the front end of the spindle nose. These index plate, in simple indexing there are a index plate. In simple indexing there are a index plate. In simple indexing there are index plate. These index plate are 24 number of holes. These index plates having 24 number of plates, 24 number of holes. These simple indexing or direct indexing have an index plate which contains 24 number of holes, 24 number of holes, and uses bevel gear. 24 number of holes is used. Sorry. For indexing the pin, first what happen? This is the index plate. This is the index plate. For indexing, what are the methods of indexing? How indexing is done in this direct indexing head? For indexing, the pin is taken out first and then spindle is rotated by hand. Means this is the index plate. This is the index plate. This is the index plate which contains 24 number of holes. And here crank pin is present. Here crank is present. Here crank is present. Here crank pin is present. Here crank pin is present. First crank pin is engaged with one of the hole. First crank pin is engaged with one of these hole. Then first disengaged crank pin. This crank is disengaged from this index plate and then rotated by hand, and after the required position is reached, it is again locked by the pin. Suppose we have to divide the workpiece in 3 equal parts. This is 1, this is 2, this is 3. After this rotation, this index crank is rotated. In this case, this index plate in this hole is locked. This index plate in this hole is locked. When the plate is turned through the required part of the revolution, the dividing spindle and the work are also turned through the same part of the revolution. With a rapid indexing plate of 20 holes, it is possible to divide the work into equal number of divisions of 2, 3, 4, 6, 8, 12 and 24 parts, which are all the factors of 24. Means if we use direct indexing, in direct indexing 24 holes are there, 24 holes are there, 24 holes are there in index plate. If we use direct indexing, then we can divide the workpiece into any number of equal parts. That number of equal parts is the factors of 24. These number of equal parts we can produce with the help of direct indexing is what? Now 2, 3, 4, 6, 8, 12 of 24. 12 and 24 means we can divide the workpiece by using direct indexing. We can divide the workpiece into number of equal parts by using direct indexing. Is 2 parts are 3, 4, 6, 8, 12 and 24 means all the multiples of 24. All the multiples of 24. Then it's simple. Then to find the index moment, to find the index crank moment, means which to find the index crank moment, find the index moment, find the total number of holes in the different index plate by the number of divisions required in the work. If n is the number of divisions, means this is 24 and we suppose we have to produce these circles into 6 numbers of equal parts. 6 equal parts. What happens? Now this 24 by 6 means 4, means this index plate, then number of index plate, this index crank rotates, then this index crank rotates 4 holes of 24 hole 24 hole circle plate. 24 hole circle plate means if there are 24 plates, if there are 24 parts, 24 holes, the 4 holes to be covered to produce 6 equal parts. Then we will go for simple indexing. This is direct indexing. What are the limitations of this direct indexing? Then why we should go for simple indexing here? Now because in direct indexing we cannot produce any number of equal parts. Here the parts is produced. The number of equal parts are produced with the factors of 24. So that we cannot produce any number of equal parts. For this reason, we go for simple indexing. Simple indexing is also called as 9 indexing. It is more accurate and has a large range of indexing than rapid indexing or plain indexing or direct indexing. For indexing, the dividing head spindle is turned by the index crank. The worms up here, worm and worm wheel is used. In simple indexing head, worm and worm wheel is used to produce equal number of parts. Worm and worm thread is used. In worm wheel there are 40 teeth. In worm wheels there are 40 teeth. In worm wheel, worm and worm wheel is used. In worm and worm wheel, is used. This worm wheel has 40 teeth. Means one complete rotation of worm equals to one rotation of one teeth. One complete rotation of worm equals to one teeth 1/10 rotations of a wormhole. 1/10 rotations of this wormhole means if we will rotate completely, if we will rotate worm one rotation, then in wormhole 1/10 is rotated. Then in wormhole 1/10 is rotated. The worm shaft carrying the crank has single threaded worm, means your worm thread has single thread. Worm which meshes with the worm gear having 40 teeth. 40 turns of the crank are necessary to rotate the index head spindle through the 1 revolutions, means 40 turns are required in worm to completely rotate a wormhole, means 1 rotations of worm is 1/40 teeth of wormhole. This is the details of dividing angle. This is the simple indexing head. Imagine this is the arm for locking. This plate, this worm plate, this index plate. This is the index plate. This is the index plate. This wormhole has 40 teeth. If this is rotated 1, then 1 teeth is rotated of a wormhole. This is the index plate containing different circles. Then therefore, 1 complete turn of the index crank will cause the wormhole to make 1/40 of a revolutions, 1/40 of a revolution. To facilitate indexing to the fractions of a turn, and index plate is used to cover practically all numbers. The index plate with a circle of holes manufactured by the Brown and Sharp company, plate number 1, 15, 16, 17, 18, 19, 20. This is the one plate, this is one plate, this is one plate. This is the simple indexing head. To find the index crank moment divided, divided 40 by number of divisions required on the work, index crank moment, where n is the number of divisions required on the work. Suppose example, suppose we have to divide this workpiece into 10 number of equal parts. 10 number of equal parts. So, we have to divide 40 divided by 40 by 10 means 4 whole circles. It means it will cover 4 whole, means index crank cover 4 circles, 4 holes, 4 whole circles. Suppose we have to divide this workpiece into five number these workpiece into 3 number of equal parts, 3 equal parts. These 3 equal parts, then what happen? We have to divide this 40 by 3. Then what happened? This is means 13 into 1 by 3 means what happened? Now, to produce 3 equal parts on the periphery of the workpiece, we have to move the index crank into 13 complete rotations. Then we have to find these 1 by 3 rotations. It is not complete. When the index crank will turn 13 complete revolutions, then it is not complete. Then we have to these 1 by 3, then we have to multiply. In numerator and denominator. Equal numbers or common in, we have to multiply a common number in numerator and denominator. So, we have to produce a available whole circle. Suppose we have 12 hole circles. Suppose we have 12 hole index plate. Suppose we have 12 hole index plate. 12 hole index plate. If we multiply these two and numerator 2 means it will give 2 by 6 means 6 number of hole plate we have not available. Then we have to multiply 3. 1 by 3 divided by 3 by 3 means 3 by 9 means we have not 9 hole index plate. Then we will go for 4. 1 into 4 divided by 3 into 4 means it will give 4 by 12 means in a 12 hole index plate we have this index plate means in a 12 hole index plate we have go for 4 hole circle. We have to go for 4 hole to means in a 12 hole index plate we will go for these 4 holes. In 12 hole index plate we will go for these 4 holes to find 3 equal divisions of the workpiece means 13 divisions of index plate, 13 divisions of 13 complete rotations of the index plate and also 4 hole, and also in 12 hole index plate we have to complete 4 holes to find or to divide 3 equal number of divisions of workpiece. This is one numerical. Find out the index moment required to mill a hexagon bolt by direct indexing. The rapid index plate has 24 holes. Here we can find, here we can use direct indexing. Why we can use direct indexing? Because here hexagonal means 24 has a factor 6. So we can directly go for 6 divisions in a 24 direct indexing, but 6. Then next set the dividing head means 24 by 6 means 4 hole circle means in a 24 hole index plate we have to cover 4 holes. Index crank should cover 4 holes to find 4 equal parts. To find 6 equal parts. Then another example, set the dividing head to mill 30 teeth on a spur wheel blank by simple indexings. Here simple indexing means simple indexing and 30 teeth. 30 teeth here set the dividing head into mill 30 teeth. 30 teeth should be produced means 30 equal parts should be produced. 30 equal parts to be 30 number of equal parts should be on the periphery of the cutter. To produce 30 teeth means 30 equal parts should be produced in a simple indexing. We know in simple indexing worm wheel contains 40 teeth. Worm wheel contains 40 teeth. So we have to divide 30. 30 means this is 3 by 4. 3 by 4. But we have not these 4. But we have not these 4 hole circle, 4 hole index plate, we have not this 4 hole index plate. So what happened? Now this 3 by 4 can be converted into 1 into 1 by 3 means 1 full rotations of these index plate, 1 full rotations of these index plate and this 1 by 3. These 1 by 3 should be converted to available number of index plates. This 1 is multiplied into 1. Then we will see, then we should see what index plate is available. Then we should see what index plate should be available. Then as required, then we will multiply these in same common numbers in numerator and denominator in order to find out this available number of index plates. Suppose we have 7 hole circles in suppose we have 21 hole circle available. Then if we will multiply 2 by 6 not available. If we multiply 3 by 9 not available. 4 by 12 not available. 5 by 15 not available. 6 by 18 not available. If we will multiply 7, then 7 by 21 means this denominator will provide, this denominator, this is 21 whole circle is available. This in 21 whole circle index plate we have to cover 7 holes to get this 30 equal number of divisions. To get this 30 equal number of divisions means the numerator in this is numerator and denominator. This denominator is the number of whole index, number of whole circle index plate, number of whole circle index plate. This is the number of whole circle, this is the number of whole circle index plate. Thank you.